Okay, we're happy to have Hamdi with us today. And Richard, are we all set on the recording? Okay. And talking about the important topic that Andrew always cares about, validation and verification. So take it away, Hamdi.
Thank you very much, Rob, for the introduction. My name is Hamdi Kavak. For those who don't know, I just want to give a brief background about myself and my research. So I am an assistant professor here at the Computational and Data Sciences Department. I started last fall, so I'm one of the latest hires of the decade. And prior to starting here, actually I was not that far away. I was at the Geography and Geoinformation Sciences Department, and I was doing a postdoc on a DARPA-funded project. And prior to that, I was at Virginia Modeling Analysis and Simulation Center for almost 6 years, and I did my actually PhD and all research work there as well. So, for those who don't know me, I would like to just give a brief overview about my research. So, you know, when you do research, you advance something. And that something in my case is two things. One is the domain knowledge using computational methods. The other one is advancing the field of modeling and simulation. So what I did for the, advancing the domain knowledge is that I made contributions in the urban science urban science area. Basically, I worked a lot of Twitter data, especially spatial data on Twitter. So one of the projects that I did was like, how can we predict people's home location without they telling us? And I did that, and I published a paper 2 years ago at SPP BRIMS conference. And that was using also Twitter data. And another project that I did was looking at people's movement, especially when they are moving as a tourist within the city. And for that, I created a study and analyzed people's sentiment, movement patterns, etc., and published the paper in PLOS One the other year. And there are also some studies that I conducted that are not published yet, still again on the human mobility side, understanding people's people's movement patterns, especially things that we a lot of see in the papers of like cell phone data analysis, like people's radius of gyration, what are the patterns when people visit multiple places, and what are the common places they visit, and so on. And that was on the urban side. And on the cybersecurity side, I did a study on the malware projections. So basically modeling the Wi-Fi routers in an urban area and trying to predict what would be the potential malware projections outcomes. And I did that for Washington, D.C., and the results were pretty interesting in terms of security implications. And prior to that, we did some study on the malicious behavior modeling. So this was an agent-based model. We were trying to understand what theories, so what behaviors would be the most effective when it comes to people's like becoming malicious actors in cyberspace. And we did a lot of like theory-based modeling there. And finally, on the cybersecurity side, so I recently got a paper accepted on an Oxford journal about like how can we use simulation for cybersecurity. So that is the like a overview topic, but it was also giving a lot of insights about like what is coming next. And in terms of modeling and simulation fields, my dissertation topic was about data-driven agents. So basically, when we develop agent-based models, most of the times what we do is identify behavior rules of agents, and then we are trying to simulate something. But in data-driven agents, the idea is that instead of providing an explicit rules, just gather those rules from data sets and try to explore different options, the system that we are interested in. And that was mostly in human mobility models again. So another topic which is somehow related to today's talk is about web-based simulations. So one thing that we noticed was like simulation tools are built by experts for experts. When it comes to like middle school students, high school students, even undergrads, it becomes difficult if they're not technically sufficient. So while I was at Video Modeling Analysis and Simulation Center, we developed a tool called Clouds. And that Clouds is a web-based discrete event simulation tool. You don't have to install anything on your computer. All you have to do is just go to the website and create an account and just start building your simulations right away on the browser. You don't have to install anything, and it has super neat features like you can capture your own data and you can put it on the simulation without any interference. And everything you run is running on the cloud, so you don't need any computational power either. So that project was a huge success. Actually, nowadays I think it's available in 7 languages and used by people over 70 countries all over the world. And that project inspired a lot of things. One of them was like understanding the modeler project. So as I said, the Clouds is a discrete event simulation development tool, and while people using that, they just drag and drop things. They don't write code, but they drag and drop things. They wire 2 different blocks to each other, and they run simulation. They face errors, and they also sometimes successfully run the simulation. So we collected that data with user consent, of course, and then analyzed how modelers behave when they are novice, when they are experienced, when they are advanced. And there's a paper that we submitted, is coming out very soon, hopefully. And lastly, I have done efforts on the verification and validation. One of them, actually, where I met with Joe as well, was at this Swarm Fest when we presented this paper, Spatial Plots to Convey Simulation Dynamics. So basically, we were trying to use heat maps to convey simulation dynamics information that we cannot do in like regular 2D plots. And another project was statistical debugging, so trying to conduct verification and validation by providing certain constraints into the tool, and then trying to understand what would be the potential cause if there's an error in the simulation, and so on. And finally, actually this is today's project, is making a verification and validation service. So let me briefly start with what do I mean by verification and validation service, and then we will go deep in detail. So for those who are familiar with modeling and simulation processes, verification and validation is perhaps one of the most common steps you might see in almost many modeling and simulation processes. And when we look at the literature, one of the co-authors of mine actually is preparing a paper for this. There are over 170 verification and validation techniques available on the literature. And many of you might be surprised because we don't use many of them. We are just doing whatever we used to do, and I'm going to come to that point as well. So despite...
regardless of the model, regardless of the, I mean, that's not just Asian-based models.
That's a general modeling and simulation field. Yeah. So despite that, the verification and validation is one of the most important steps in the modeling and simulation process, and there are lots of available techniques. The surveys of people who are actually developing these models for the industry and for academia says something different. They say that they usually conduct verification and validation in an ad hoc manner. So they don't necessarily follow any rules when conducting that. It's more like trial and error.
There are rules?
It's difficult.
They don't apply to you, don't worry, Ken.
And surprisingly, some people do not apply any verification and validation techniques at all. They just develop the model. See? That's easy, right?
Would that be considered a method?
The null method.
That's one of the 170.
Like, is it 171?
0 is an integer.
Actually, matter of fact, yesterday I talked to my colleague. He said he found some others, so it's over 180 now. Anyways, so the project is trying to improve the VNV practice by implementing a VNV service, verification and validation service, and I will use VNV and verification and validation interchangeably from this point on, for people who are not only experienced but also people who are novice, who are not really technically sufficient. So this is the idea. So let's
I
talk.
mean, just one quick point is that
Sure.
so in the federal world there also is the idea of accreditation of the model.
Yes.
So is it generally going to be that's the same things apply to accreditation, or that's a whole separate topic?
No, that's a separate topic. And the accreditation part is for their use, for the government use. It's not for the general purpose. Yeah.
So you're referring to verification and validation as a single step.
Normally, when we look at the literature, they were separate. Like I will come to the details, but in the 60s, 70s, when you look at the literature, they are discussing them separately. But from the early 2000s and from the 90s, they started merging those two topics. And we did like a paper, actually now on +1 under review, looking at the 4,000 modeling and simulation papers using content analysis and see how the evolution of VNV or verification and validation separately. And that's the pattern that we saw. That's why I put those together. But I don't mean they are the same thing.
So the 170 are going to include,
Yes.
maybe whatever, are going to include some things that were really only verification,
Yes.
some things that were only validation, and some things that
Combination of the both. Yeah.
Okay.
Yeah, because nowadays we develop models.
Baseball player and a football player.
Yeah. So nowadays we develop models, especially this is the case with agent-based models, is that it is difficult to understand if the behavior that we see is from an error in the simulation or it is because there's actually the pattern that we see is correct. So it is very difficult nowadays. That's why some techniques apply to both.
Okay.
I can share you some papers
No,
about that.
yeah, I see it.
So let's talk about who is trying to do this project. So this is our not very interdisciplinary team. So myself, I'm leading the project. We have Jin-Suk Kim
You
here.
smile?
Hmm?
You can smile?
Of course. So we have Jin-Suk Kim here, who is also part of this project. He is doing on the technical side of the things, and Christopher Lynch, who is actually doing this verification and validation literature review and a lot of study on that is from VMAS, my colleague. And we have an undergrad student who just started working like last month. He's an economics major here. And of course, over time, we will have some other hopefully positions, and if we are able to find some funds, I would like to increase this team. So let's a little bit talk about the VNV terminology. So what do we mean by verification and what do we mean by validation? So when we say verification, we are looking at whether the model is built correct or not. So this is basically related to model code. We are saying whether the code is written in a way that it is correctly representing what we intended to do. And when we look at the verification literature, it involves like checking the structure of the model, checking the code, like debugging, and also looking at the behaviors to identify implementation errors. So validation.
Hang on, before we go to validation, so obviously there can be many different levels of this, right?
Yes.
And only in the best possible circumstances can you do it exhaustively, say, right? So, I mean, I guess I'm reminded, so, I was talking to Nicola today that NASA Goddard used to run a workshop called Formal Analysis of Agent-Based Systems, where they would use all this model checking stuff and everything, right?
Yes.
And then, at the last conference they had, one of the speakers was from AMD, the chip maker, and he said that in the move from 32 bits to 64 bits, no longer did AMD exhaustively check that every possible input combination gave the right answer anymore. With 32 bits, they actually did. The chip was logically not flawed. But 64 bits, you can't do that anymore. So I mean, presumably, even though you can check your code is working right, the fact that it's running on a busted chip is not something you're going to check, right?
Yep.
So there's always a limit to what can be done with it.
Yeah, of course. And in any software, you can't be sure that it's error free. I don't remember the quote, but there was a quote about that.
Right. Well, there's some people try to do the logical testing of it, right? Be sure it doesn't deadlock or something like that.
Yeah, those are concurrency tests. Yeah.
So it's the process of, but then will it please the manager of your project if you say, well, I tested it for 5 minutes and it seems failed, verified, versus if I tested it for 5 years and it seems verified. Those are different levels of verification, obviously. Right?
Exactly.
So it's not a binary thing, but we don't have any standard scale either for
Actually, that's also a research topic. Like, can we come up with a scale?
Okay.
So the landscape is, I've done this a lot. So
Mhm.
the landscape is very ugly because there's no scale. There's really no formal terminology. I mean, I would guess, we looked hard at your 170, there's a chance that a couple of those are the same thing.
Yes.
Yeah,
There are
but
overlapping
it would
things.
have been a nightmare of you guys to try to figure out, work out the math in somebody's poorly written paper and say, oh, wait a minute, that actually is the same thing as number 67. So that's crushing us, and
Yes.
it's just, right. If you look at the DoD instructions, you find they're incredible. Basically, they say, go to an expert. Which I guess is gonna be us. The good news is, I think the customer base is the good news in terms of trying to deliver a product, is willing to accept this is a confidence building exercise. So maybe it is, they won't accept 5 minutes of work, but they will accept 3 months of legitimate, experts working on the subject. So
Glad that you mentioned, because in the end, verification and validation is a way of increasing the confidence on the model. So, what do we mean by validation? The process of determining that a simulation adequately reflects the model system. So whether the model that we developed actually, assuming that it's error-free, which most of the case not, assuming that error-free, we are looking at whether it reflects the reality or not, or the thing that we are trying to simulate. And for that, examination is a vastly, like conceptual model examination, output data and its uncertainty estimation, and sensitivity to parameter changes. You can name many other things as well.
So Hamdi, I don't want to quarrel with you on a matter of English, but I think that you're using the word model and simulation roughly equivalently, right?
yeah.
And I wonder if you would admit the idea that a simulation is a realization of a model.
Running the model over time is simulation. Yeah.
Okay.
But if you don't run the model, meaning simulate, it is very hard to validate it. That's the also problem. So,
But with the following exception of that, there are many computational models that are not simulations. That's
Yes.
Mhm, yeah.
Yes. Most system dynamics models, but not simulations. You've modeled it as a series of differential equations.
and you run them.
You turn the crank once.
Why do you have
You solve those differential equations. You turn the crank once because it's deterministic.
No, I know, but why do you have to go so far? You can just say a regression is not a simulation.
Right. Regression
Regression
is
is
simulations.
all.
Yeah. Lots of. The statisticians use the word model.
Mhm.
They don't do any stimulation, but they'll talk about modeling like crazy.
So this is about simulation models specifically, like discrete event,
Models that lead
agent-based.
to simulations.
Yes,
Um,
exactly.
Hamdi, will you talk about why we need verification to begin with? At some point, I have a question.
Sure.
So why do we have to do verification and agent-based modeling and no one else has to do it? Because everybody's running their code Why don't people that run regressions check if the regression ran correctly? I mean,
Because you
why is
want-
that only part of the domain of agent-based modeling?
No, it's not domain of agent-based model. It's any simulation model.
Or
So
the domain of
it-
simulation.
So the simulation model in this context is a software, and you have to make sure that the software is error-free to an extent.
Yeah.
Right, but when we go to publications,
Yes.
everyone, at least everyone is using a computational model.
Yes.
No one else verifies. No one sits there and goes through the code and makes sure that the answer that they get is supposed to get when they have a certain input. Only the domain of simulation is expected to produce verification sections for publications, but no one else, even if they use like machine learning, do verification.
I think it's
Why is that?
Yeah, it's partly related to the tools that we use and the paradigms, especially for agent-based models. We don't have like a formal mechanism to develop agent-based models. Like in Mason that we usually use, you just write the very basic, very low-level code, and which is error-prone. But when it comes to tools like machine learning tools, they are like only blocks, and they are verified independently outside. And you're just using something that is already verified. I think that's kind of the reason.
Because
Like
it's bespoke, because it's custom.
yeah.
I think I would half agree with you. I think a lot of data science doesn't have is not scrubbed with this brush. But you go into an optimization model, for example, and you get to verify that that's in fact giving you the optimal solution with the right with all the inputs and all that stuff. So there's no simulation involved in those, but that's a model that we frequently deploy. And sure, you got to do both verification and validation.
But to give Joe's points due, though, I mean, how about take kind of an extreme case, which is kind of nonsensical, which is imagine if the federal government couldn't buy any software unless it had been verified and validated. Okay, and then when we say Microsoft Word, is Microsoft Word verified and validated? It is not, right? It has all kinds of bugs and flaws. It's going to crash, etc. Right? So that would mean the federal government wouldn't be able to buy Microsoft Word. I mean, in the extreme case, right? So, I mean,
By the way, that's what the regulation says.
that's what it says.
It's what it says now.
It
Not
says
accredited.
that. And it's ignored. It's just you know,
Yep.
because we prefer not to bring the base law, you know. It's
Okay.
bad.
But it's also that we're talking about a fully capable language that we're writing our model in, as opposed to an architecture which makes and restricts what you can do to the architecture, and the architecture has been backed up, and now your model runs on that architecture, and the validation verification is to the specific experiment that you're running, not to the performance of the model, because it's running on an architecture.
That would be a rational proposal I would
Yeah.
put forward if we're, you know, if we were delivering a model, I would say exactly that. Hopefully it would be accepted.
Well, but would it be different so if I'm delivering the source code versus I'm delivering an exe file? Because it may not run on a different JVM, for example.
You're right.
What I was referring to was ACT-R is a cognitive architecture, so the models that you build and run in ACT-R are running on a system that has validation verification going down to neuroscience and imaging. So you're building on top of that expertise, that engineering in a sense. And you don't have the full flexibility of an open language.
Because otherwise you're requiring everybody who delivers a document to verify Microsoft
Do the
Word.
whole thing.
Yeah.
Yeah. Okay, we've picked on this slide. You want to move to number 6?
He's got 73.
Yeah.
So a little bit background on modeling and simulation processes. So this is the one on the left is from Sargent. He published this diagram for like 30 years ago and still publishing the same diagram, the same exact way. So it is one of the most commonly referred modeling and simulation diagram, which is showing like if you have a problem entity and you develop a conceptual model and you develop a computerized model out of that. And the reason why I'm showing this because there's like an operational validation part here and verification part here and also data validity and conceptual model validation and so on. So this is one of the commonly used, and it has modeling verification and validation in it. Talk et al. This was published in like 6-7 years ago. It's based on the systems engineering principles, and it is looking at the system and the reference model, modeling question, conceptual model, and simulation model, like a top-down approach. And in every step, there is a validation and verification process that iteratively goes back to the previous steps that you have conducted. And finally, this is from Balsi to 1998, life cycle of modeling and simulation. And this is like a, like you were talking about the accreditation, verification, validation. This Balsi is one of the guys who actually developed lots of protocols for that. And this process actually goes down all the way there, and there are like every single step has verification and validation and quality assurance. So this is something that is used in, that is seen in almost any practice that we see.
I have found that data scientists, I agree with all this is all great stuff, this is what I do, right?
Mhm.
Data scientists throw this out. Data scientists believe the data is the model. So they're not doing a system, they're not creating a system like Tolk says. They're not creating a paradigm of the system. Whatever's in the model, the machine learns it, and the relationships, the rules, the boundaries are all learned by the AI, perhaps not even stated explicitly.
Yep.
And then I move straight to the middle of the diagram.
Yeah. And that's a problem, because like if your data is biased, then there's a lot of conforms that is
Or
open.
if your system's changed.
Yeah.
Yeah, but like in the same note, system data is biased. What if the system does not count all the anything that changes the environment? You still,
Yeah.
how does that work? So it's kind of twofold. You can't pick on any one, right?
Yeah. So while that was the case, verification and validation is everywhere in the modeling process, but what does the practice say? There are a lot of challenges because of the resource requirement, so time requirement. People either do not conduct validation verification at all, or they just conduct very informal techniques and very short, and then say like the model is valid for this purpose. And tradition of use, people learn certain ways of conducting VNV, and then they continue that way. They don't change. They don't look at any new techniques that are developed lately. And there's a high learning curve, especially for formal techniques, like when it comes to statistics-based techniques and some like logic-based techniques. It requires some background in math and logic. And of course, there is also lack of commonly accepted solutions, which yields you verify and validate one model, and you no longer use that for another model. You have to almost start from scratch, which means that you lost a lot of time. So what is proposed here? So it's a schematic view. We are going to go into details as well. Assume that there are n different simulation models. Each color is a different simulation model. And of course, a simulation model generates data. And simply that data is acquired by this VNV service. This is the idea. And in that VNV service, you will be able to manage that data, meaning you'll be able to group the data in a way that you identify replications. Like you run the model like 100 times, you can group them in this system. You can explore data, you can look at the summary statistics, histograms, counts, and so on. And you can also like do operations on data, like delete column or data itself. And on the right side of the VNV servers, there are techniques. I identified three types of techniques. One are the basic types that people think that come into your mind in the first place, and statistical techniques and formal techniques. So the interesting part of this service will be a VNV technique recommendation system. So basically, the system is fed with data from previous simulations, and because of the shape of data, type of data, certain verification and validation techniques is a good fit for it. And we are planning to implement a machine learning or how people call nowadays AI system, that would learn how people match data with techniques, and then whenever new person comes, loads their data, and it says like you can apply these techniques. So it's one of the things I think that will be useful in this system once implemented. So what are the techniques that we are talking about? Basic, statistical, and formal. So basic techniques, mostly visualization and animation. So scatter plots, time series data visualization, spatial histograms, heat maps, and so on. So these are the basic visualization. For the animation, like traces, animation of, especially this is like very important for agent-based models, tracing an agent, how it behaves over time, and like events happening in the system. And these are all gathered from the literature of what people proposed. And event validity, whether the sequence of events are valid or not. In terms of statistical validation techniques, like historical data validation, confidence intervals, statistical tests, distribution fitting, like network measures if you have a social network and so on. These are all based on the simulation output. There's also sensitivity tests that can be conducted based on the input and the output of the simulation. And there are also some formal methods like boundary checks via predicates, like single predicates or combined predicates and so on. And there's a paper that we published called BNV calculator via statistical debugging. So it's an advanced version of this predicates telling you what would be the likely cause of an error in an agent-based model based on your specifications. All right, so how are we gonna implement this? So this is the system architecture that we are thinking initially. This might change over time, but this is the initial architecture. So basically, this is a web-based system. There's a client library which looks at the connection with the data interaction capabilities, and some VNV tools. Visual side of those are all on the client side. So user is not involved in doing anything in terms of like data loading and so on. And there is a simulation which pushes data into a data aggregation system, and that data aggregation system pushes the data into a data store, and data store can access to VNV techniques or libraries that are on the back end. This is all in the back end, and there's an orchestration process that deals with all these single things here. And the initial software that we identified for these are, for instance, for the front side, we're gonna use, actually we started using Bokeh, which is a Python-based dashboarding solution, which allows you to use like very interactive visualization tools, but also allows you to create your own custom verification, custom visualization and data intense applications. And on the data aggregation, Apache Airflow and NiFi is going to be the tool that we are going to test. And on the database, PostgreSQL is one, and we're going to also try to look at the distributed database solutions, CrateDB, CockroachDB, and Couchbase. I know they sound weird, but these are one of the like good ones on the market. All open source, by the way. And for the orchestration, Kubernetes is going to be the one that we're going to try, see if that is a good one. And finally, for the VNV implementations, we're going to develop microservices based on Java, Python, or whatever language we find useful for that.
So this is just the architecture for the actual testing of different methods?
So this is the architecture of the system that would include those techniques.
The system that you had on the last slide.
What's
right?
that?
The system you showed on the last slide.
Yes.
You have the
That's
output
grayed out.
data, and then your AI is going to make the recommendations to what.
Yes.
Yeah.
Yeah. So this is a schematic view.
Schematic view. How are you gonna implement that architecture?
Yeah, this is the how you implement
So
it.
why do you need multiple databases for this? Why don't you just pick one?
So I will come to that point, but because there will be a user-based use of the system, like you want to log in and try to use the system, and for user information, the best way to store is like on a regular SQL databases. That's why we put like PostgreSQL, and these are more things that does not require ACID things on the website. Okay. So, what are the planned features that maybe will explain this? So, in terms of user experience, the idea is that to have like seamless integration of data logistics for the user. So, this requires to develop certain adapters for individual libraries and simulation tools, which is a tasking thing, but it is going to be one of the good things, so that the user will have minimal interaction with the system. And the personal data via user management. So this is basically a user management system on a website. And ability to recognize replications and certain data types. This is also important feature. Like if the data that user pushes has a spatial component, the system should be able to say like, if this is a latitude and longitude, you can just visualize it. Maybe it can ask like is this a latitude longitude? Then we can show like spatial visualization techniques are good for that. And third-party integration with the web-based simulation tools. So I will come to that point later. And one idea we have is that the custom reporting dashboard, which will allow a person, when they go through all the techniques, etc., and they will be able to create a dashboard and then show that what steps or what techniques are conducted on their data, and they can show their results via a shareable link. And this could be a supplemental for papers as well, research papers. So in terms of the system, the idea is that it's independent of the simulation method or software tool. So the simulation, the system will be agnostic to those. My main contribution, I believe, will be on the agent-based simulation community, because that's the one that struggles with the verification and validation questions most of the time. But I also think that discrete event simulation, system dynamics people also would benefit from this. And also self-evolving VNV technique recommendation system, the one that I showed in the middle. It will be hopefully self-evolving, so we don't have to tell it what to do.
So, forgive me for asking sort of an elementary question, but I was looking for the data on the response variable, the real world, that is necessary for validation to work, right? Where did that flow through the system? Is that has to be there, right?
Can you repeat the question again?
You can't do validation unless you have some data to validate against.
You can do actually, but let's assume that that's the case, because you could do like a theoretical checks without like having a data inputted into the system. Like you know that the output has certain shape, and then you look at that and you can say that like it looks valid.
Oh, I see. Do you understand that output population?
Yeah.
It's a population
Yeah.
distribution. Then you don't necessarily need
But that's a good question, because that's one of the things. Like I put one of the examples, like historical data validation, which is like you will be able to import historical data or tell that my data is like normal shape, mean is this, standard deviation is this, and you will try to check whether that holds in the simulation output as well.
in geospatial, of course, it gets rather challenging.
Yeah, exactly.
Because are you gonna,
Aggregation.
validate that the distribution of mini mansions in Northern Virginia are gonna match what they really are? I mean, whatever it is.
I mean, that's a challenge regardless of this tool.
Yeah, well, I would agree. Yeah, okay. But there has to be a feed into the thing where the real world's outcomes
Yes.
go in there and get compared
Yeah, agreed.
in some way.
Yeah.
Are you doing static source code analysis on the verification side?
No, this one assumes that simulation generates all the necessary data. We are not dealing with the code itself.
So if you're not actually looking at the if you can't observe the behavior of the program except through its outputs, well, first of all, is that correct?
Yes.
Then how are you doing specifically the verification step?
So the verification, I showed like 3 bullets. 2 of those bullets are about like checking the code and checking the code structure. Those we can't do. But behavior of the code outside, the things that go outside of the model, or manifested as a behavior outside of the model, that can be checked via this. So it assumes that you at least did debugging yourself and conducted code checks yourself. Yeah.
Okay.
The list of methodologies that you came up with earlier,
Mhm.
in the earlier slide, we talked about basic and the 3 bars.
Statistical, yeah, and
Yes.
formal methods.
Is that exemplary, or is that
Exemplary.
the scale of, okay.
It's exemplary, but somehow a representative and relatively easier to implement for us, because for instance those formal methods, we have already implemented them in a paper, and we can put them here as well.
I see.
But the others are mostly they are easier to do at this point. But by no means that's the limit.
Yeah, you look like you picked a list that was fairly easy to do, but you get power law output and your life gets hard.
Yeah.
That list is not going to be adequate.
Yeah. So, so the project actually, the idea of the project was I can say at least 4 or 5 years, but actual implementation and forming of things just started last month. So the Peter, undergrad student, developed some server apps, just looking at some simulation data on the server side, and then visualizing that on the browser. And 3 things that he was able to develop. One was time series data visualization. The other one was trace data visualization and animation, and the third one was network visualization. Let me show you those really quick. So. Let's see. No, it doesn't appear there. Do I have to drag and drop there? Okay. So this is a output from a simulation, agent-based simulation, looking at the population unhappiness, average network degree over time, and based on the time scales, you can actually squeeze and look at different aspects of the data, different time frames. This is average network degree. You can
What's
inspect.
What's being simulated here?
So this is an agent-based simulation output,
Yeah.
which is looking at the average network degree and percentage of people unhappy, etc. in a simulation model over time. This is just for exemplary.
Oh.
And that was one. The other one is trajectory data. So it's a random walk display of 10 agents on a spatial environment. You can identify how many agents you want to show there. You can identify the time frame again. These are just proof of concept for now. Just zoom in. Finally, there's another one, the last one. This is a network data. Actually, this does not come from a simulation. This is a karate club data, but it is still valid because it's loaded from the server side and showed on the browser. There are the intergroup, in-group connections, and you can just inspect this data as well. So the roadmap, as I said, the kickoff was last month, and then the idea is that within this year we're going to create those basic VNV tools and create an interface sketches and some use case diagrams and some microservice implementation. Hopefully, that's the idea. And we need to. So those visuals that you saw was out of Bokeh, and it is like already available. We want to customize Bokeh in a way that we can implement anything we want. And hopefully we're going to do a distributed database test and integration and some prototype user interface by the end of the year. And that would maybe mark the private alpha. And then from 2021, we're going to do like data management features, user management features. So user related things will come a lot later because there are lots of things to be checked before. And hopefully by mid next year, we're going to implement the more advanced VNV tools. And library integrations, probably we're going to tackle first Mason and see what we can go with that. And then the last thing will be the orchestration and public data by the end of next year, all contingent upon funding. So what are the initial challenges that we foresee at this point? Tool library integrations will be one of the first challenges that we will face, because especially for agent-based modeling community, there is the tools that we use do not have standard data collection mechanisms. So that will make our lives a little bit harder, and because of that, making users minimally interrupted from this will be a little bit difficult. So especially Mason users will be able to will learn a lot of things that maybe like any logic users don't need to learn. And auto recognition of data types and important columns, this will be a challenge. But there's a study out of MIT, Cesar Hidalgo, who left actually there, looked at like selecting data, recommending a data as certain visualization tools using machine learning. So we're gonna look at their papers and try to gather things that might be useful here. Of course, computational cost there will be a financial cost because all of these will be running on a cloud system. So, if successful, so what will be the implications for research? So, I wholeheartedly believe that it will improve the VNV practices, thus it will move modeling and simulation field forward. So that will be one of the most important contributions. Especially, I think exploration and validation of massive simulations, especially agent-based models with millions of agents. This system hopefully will be able to let those developers explore their data, conduct verification and validation that is challenging in their single computer. And the VMB recommendation engine can change the way we conduct verification and validation. We may come into new verification validation techniques that we don't know of is applicable to our model, applicable to our data. And finally, and this is the one that I'm really picking on, is like seamless integration with web-based or cloud-based systems. So there's a tool called Insight Maker, which has like agent-based modeling and system dynamics on the browser. Clouds is the discrete event simulation version that I worked on. And there's a new one called Hash. I don't know if you've heard about it. It's a new startup built by the owner of Stack Overflow, based on New York. And they're coming with an agent-based version that is running thoroughly on browser, on the cloud. And the good thing about these type of tools is that they are so restricted in a sense that we can integrate our services like this VNV service without big problems that we would have with Mason and other library-based tools. And these are some references that you saw in the initial slides. And thank you for listening.
Questions?
You seem to be aimed at commercial agent-based systems rather than research agent-based systems.
I mean, I think it's a little bit early to say that. I think it's good that to be open to both sides at this stage, but main idea is to help the researchers, not the commercial area. But I'm not saying that it is not a possibility.
Okay.
So you highlighted this is going to have a computational cost, and
Yes.
how do you propose making it available to this wide group of folks and offsetting the computational
so-
cost and investment that will be required?
Yeah, so for instance, that Insight Maker tool, we've got $80 million funding from NSF for that. So there are NSF programs that are aimed at things like this. There are not a lot, and I don't know if we'll be able to get them, but I will try. As I said, most of the things are contingent on the funding.
Presumably the range of ways we want to validate a model is not necessarily limitless, but there's a lot of possibilities and ways you can combine different methods. So how do you build that into a system in a way that's useful for people without it becoming so complex and hard to use that it's impossible to use?
So if the techniques are too complicated, you're saying?
Well, or if there's so many possibilities, like somebody wants to do a slight variation on it that you haven't implemented, it's like, I don't know much about this area, but I imagine there's a lot of flexibility that an individual might want, and it's hard to build that into like a tool.
Yes, I mean that's why we are not going public for at least 2 years. So that's the idea, like we need to get a lot of user feedback. There is not such a thing as far as I know, so this will be the first one, and I don't know what will be the user feedback, which will be crucial at that point, but I don't have an answer to that at this point.
Didn't you say your answer was going to be you were going to automate the advisory system so that the user doesn't have to choose the validation methods, verification methods? The system will learn how to do that from the users who went before you.
So perhaps I'm explaining it badly, but I mean, example is, let's say you're in Excel and you're a graph, you're limited to the options that Excel's giving you. But if you were to go into Python, you can combine the code in whatever way you wanted to make, customize it to your taste, right? So I envision a similar thing here. If I was to write my own validation system as part of my simulation code, I could customize it as much as I wanted to. But here, presumably, you're going to be limited to the stuff that's implemented in the
Yeah, that's for sure. Yeah.
On page 10, if you go back to slide 10.
Which slide?
10. With respect to doing modeling and simulation, the thing that we try to do is to build our model and have input and get some output
Mhm.
to do some type of analysis or make some type of prediction. Am I
Yes.
correct?
Yes.
So, is there a distinction between the V&V that you're doing and the analysis
Mhm.
that someone would do on a model after they've gotten that data out? Because I'm not seeing like there's a big distinction between that.
So you mean more like you already validated the model and you explore.
That's
Like,
what you're when you're doing once you've done your model and you've simulated it.
Yeah.
You start doing analysis on that data because you don't
Yeah.
build the model from nothing.
Yeah, I mean that was one of the discussion we had earlier. Like, should we call this verification and validation and analysis
Analysis,
system
right.
or not? We try to limit it to V&V at this point, but I think there is nothing precludes a user doing that, as long as like they generate the data and they push it onto the system
Mhm.
some way, so they can still explore their like data in terms of like what is the distribution, how does the histogram looks, etc. They can still do that.
Emergent patterns.
Yeah.
Right.
So they can still do that, but we are not advertising that because that's not the focus.
Yeah, so and that was one of the points that I was want to make is you have that in here already.
Yes, I know.
Someone who's doing analysis, maybe not doing the prediction piece, they could use
Yeah.
at least parts of this
Yeah,
to
yeah.
do some of their analysis.
Yeah, as I said, yeah, we are aware of that,
Sure.
but we are not gonna advertise that.
Okay. Thank you.
But I think it brings up the question, and Ken just mentioned it, when you have models, Hamdi, with legitimate emergent phenomena in them, for example, for some part of the parameter space, nothing that you care about maybe emerges, but for another part it does emerge.
Mm-hmm.
I mean, I think that we don't have good software systems today which can recognize when something emerges or not.
So I think it could be part of like a sensitivity analysis, like you conduct based on the input-output relationship, and some certain inputs give you some emergent behavior, which could be visualized here as well.
Right, I totally buy in that it could be. I'm just trying to think, for example, imagine that it's 5 years from now and your system is built, okay? And I say, I want to use it now
Mhm.
to detect a novel emergent phenomenon. I'm just saying, I don't think that we have done the basic research to know when has the emergent thing happened. So I think take a very simple case, right?
Yeah.
I've got a bunch of water molecules running around. The water molecules are defined by their dipole moment and their hydrogen bonding. And I want to know, is it wet or not? I mean, I don't know what it means to be wet, right?
Right.
And I say, your system will tell me I have a valid model of water or not.
Mhm.
Well, one of the things I want to measure is it does it have the property of being wet?
Mm-hmm.
And if I don't know how to define that, then I think I'm kind of skunked.
It's like a additional thing that you need to think about. Yeah, it's not gonna be because it's a semantic
It's not
thing.
gonna be
it's not-
automatable.
Yeah, it's a semantic thing. It's not data by itself.
So you'll be able to find the emergent patterns that you're looking for.
Right, yeah. They're
Right.
well defined, that have some
Right.
automated way to be recognized.
But the things that are surprise,
Mhm.
you'd have a hard time.
So I have a colleague at VMask called Roscoe, and he has done like a lot of research on like predicting whether something is emergent or not. So he has those research, and we just co-authored several papers with him. So perhaps later we can include him to explore something like that. That would be interesting.
Predicting whether something is emergent.
Yeah.
Yeah, but we don't even know. I mean,
Or exploring. Yeah. Maybe.
Yeah.
I mean, emergence is. I mean, we don't even have a
Like the concept.
the
a
defi-
solid definition
Yeah, I know,
for
I know.
emergence is to begin
But
with.
what I'm saying is like there are research who is
Right.
tackling trying to understand those properties.
You
Yeah.
define it by it's what it isn't, and what it isn't is something that's
Right, basically anything you didn't expect is emergence. I mean, basically that's kind of what we're stuck at because I had a question about something else. We go back to this idea of validation, and the 170 ways of validating
Mhm.
something, which I don't get why there are so many. Validation in its core essence is just comparing what you have
Mhm.
with what you should have.
Mhm.
I mean,
One way. Yeah.
if I'm doing some kind of empirical test on something, or if I'm trying to model, I'm kind of getting away from toy models.
Mhm.
Why are we not reliant on what's already been developed through 400 years of statistics research and just define validation to be statistical equivalence, why do we have 170 methods? Why can't
Because-
I look at two distributions and run a KS test?
But the assumption that you come up with assumes that there's a data that perfectly represents the thing that you are trying to model, and you're comparing with that data. If that's the case, of course, yeah, that's an easy problem. But most of the things that we develop, we don't have perfect data, or we don't have data at all in some systems. So
Then what
in-
am I doing validation? What am I validating against at that point?
So in those cases, you look at maybe very high level observations. Like you don't have the bottom level data that you're interested in validating against, but you have some aggregate level which has some uncertainty in it. So you're trying to match with those. That's one option. Yeah.
Fair enough. So I'm going to give an example that hopefully doesn't hurt anyone's feelings. But there was a gentleman a few years ago here who finished his dissertation, and someone was bragging about how this person produced the proportion of some aggregate measure out of his model that was equivalent to the proportion that you saw in the data. Well, I can create 1,000 different models that produce a proportion.
Yes.
Right? It's not a specific enough part of the probability space that is not achievable. And I could do it with, what was it? Someone said, what was it, Markov or something? Give me 3 parameters and I can fit an elephant around it or something. Someone said that. So my question is, again, if you don't have clear data outputs that you can compare using the statistical methods that you already have, and you're going to look at some high-level aggregate stuff, why do we even need any of this 170 methods that already are out there? I mean, I don't understand that.
So I think you probably have to see the paper first, like why we need that type of that many techniques. The one of the important things about validation is that you're validating against a certain purpose. If your purpose is to replicate something in the real world, you try to replicate it in a way that is reasonable. If your approach is to gather some educational insight, you don't need any of those techniques, statistical techniques at all. You just need to see the output. Oh, it looks good. It looks good enough, and you are done. You are validating the model because your purpose is just educational.
Yeah.
So it's based on what purpose you have. So in that respect, like there's a validation technique called Turing test, for instance. You show a user 2 systems, 2 animations maybe. One is from the real system, one is from the simulation, and ask like which one is the simulation, which one is the real. If the user is confused, then you pass the test. As simple as that.
Interesting that you use a Turing test as the
It's
test of
one of the-
validation.
that's one of
Because
the
interesting enough,
173.
a Turing test still doesn't tell you
Yeah.
whether you've got
True.
real
Yeah.
artificial intelligence or not. It's
True.
it's a test of whether your
Yeah.
artificial
Thank
system passes a certain threshold.
Yeah.
Below threshold.
So, do we have threshold? I'm not arguing with you. I'm arguing with the whole
He's
paradigm.
defending the 170.
No,
Because there's probably a lot of invalid tests.
It's a critique of the whole,
Yeah.
the direction of
We're all
simulation research, in my opinion.
Yeah.
It's like
No.
we need to validate, we need to verify, we need to validate, we need to verify, but we refuse to use what's already been developed to do that, and we want to come up with something different. And it doesn't seem like it makes sense to me.
No, those 173 includes things that people traditionally use as well. It's not excluding them. It includes, but I'm saying they are not the only ones that is available for different purposes, different
Hang on,
techniques.
I wonder if you're chafing with Joe, for example, I mean, I think that when it comes to what Hamdi's talking about here, he's talking about a built system. So we have a federal definition of what valid is. But isn't your complaint more about, in science, we never validate a theory or a model. We, at least after Popper, we only falsify. But you can't prove that Newton's theory is valid. In fact, Newton's theory is not valid vis-a-vis Einstein, right?
Right.
So, but Einstein's theory is not valid vis-a-vis some new theory of gravity. So you never validate anything in the real. Science never validates.
Right.
Science only falsifies. So you always have contingently valid theories at the moment, but they're going to be falsified by the next generation or something, right?
Right.
So the notion of validation being used here is not the one from science. It's the one from engineering, in essence.
Yeah,
Engineering.
Oh, that's-
So,
okay.
so there is in some sense, you never validate, never truly validate the model, at least as for scientific prowess, because it's
Epstein is one of the ones who don't like the word validation at all, right?
Who is?
Epstein.
Yeah, but that's because, but certainly there are gonna be cases where you say, we're gonna launch this moon mission, we wanna have it be, as valid and verified as possible, at least.
But we don't have a lot of known missions to compare it to.
I had the recent project where I actually had to tiptoe through the literature of validation of agent-based modeling. There's a lot out in the last couple of years, including some large summary articles talking about, of course I'm going from memory, approximate Bayes, there's a whole bunch of things I suspect that made their way into U-170. You must have seen the same things I've seen out there. Long articles about this.
I mean, as I said, we are still reviewing, and there are some recent ones that is going beyond 180. Like probably some of them are including the ones.
I'll
that
send you
said.
the big one that I've got in mind. It's called a summary of. It's essentially
For
a summary
agent-based
of
models.
validation techniques for agent-based models.
But the fact that you have these and they're broad, et cetera, is that a problem for this research program, or is it actually mean that this research program is essential in order to kind of bring some structure to the?
I mean, it's like everything else, like validation in general. Somebody approaches a problem, they probably don't have his structure. They're probably using a vocabulary that's separate from him. You dig into it. I mean, we've all been here. So my guess is there's some overlap. There's some things you might want to introduce. There's going to be, it'll add to the 180, but it's a really, I think, an emergent issue. I mean, the literature, my literature search went way back, but I really found that in the last 3 years, it's getting quite rich. And a lot of people thinking and writing about the subject of validating. This is a sign that agent-based models are coming of age. That people are talking about formalizing the process of validating agent-based models, which you've got here. So
It's a specific theme for this year's SPP BRIMS conference in July.
I'm not surprised.
On validation.
On top of that,
Here's a question. This kind of links to Joe's stuff there just now. So, platform, you can use it from an exploratory point of view. Different models, whatever, play around and look at the data. Okay, this works, or you, based on data and some back-end machine learning stuff, you get prescribed different measures that could work, right? I'm a new user, don't know too much about how stuff works there. I use there's like several different options, but I get several different values, alright? Each one has some error estimate, right? Error in traditional forms, whatever, some number value or some visual or whatever. Again, and link to Joe stuff. If I'm not sort of sure exactly what the end result is going to be like, which do I choose? By default, most scientists is probably a lot of scientists are probably going to take the measure with the lowest error, whatever. And okay, cool, this is publishable, but how is your system going to offset that? Think of like implement kind of, I don't know, help users think about the idea of errors. I find in statistical, I guess, statistical models and stuff, error is a big thing, but most users don't understand error. The way to actually communicate error, to actually let users know that the model or the data, they both have different levels of error. Getting users to actually understand that, to actually make better judgment calls in terms of this is a high error, but this is the better model, right? I can accept that because I understand that better. How do you prescribe to actually get an idea of error? Communicating the issue of error, and they help people make a better judgment call and picking a better model, or picking the right approach that actually works for them. That's a very tough question, I'll just be honest, right? Nobody has ever cracked that code, right? Because as scientists, especially as academics, we look for things that we could be published. You know, all the hogwash aside, if you get bad results, it's not publishable. Most scientists will the other number looks better, we'll go with that higher accuracy or kappa or whatever you want to define it as. Any thoughts on that? I'm not asking you to implement it, right? Just
No, I mean, anything that requires understanding the semantics of the model will be difficult, very challenging, I think. So the problem of like understanding which one would work better, I don't know if that's a good idea to leave it to the user so that whatever is proposed, like the recommendation system is better. But I think that's going to be one of the challenges that we're going to tackle. But I don't have an answer to that at this point.
How would you propose to validate your model?
My model?
Not a model.
This process.
It's a meta.
Validate the process. Throw an invalid model into
He's
there.
going to survey users.
Is it going to tell you how to throw an invalid model in there? Or take a valid model, break it, and then put it in the system?
You mean like
Will
when
it
you
tell you-
use the system? Okay.
Yeah.
I thought
yeah.
we were talking about the design.
Wait, wouldn't it just be going back to my point, which is science falsifies, and I mean, right?
that's a good statement.
No, this should be a load test. You know, you do that. We do that with engineered systems.
But in the end, the idea is not to tell your model is valid or not. You're just running running your data on techniques, and you're getting some output. We are not commenting on whether that means something.
You're not interpreting it. You're not analyzing it.
Yeah, because that's a responsibility. Like there are lots of evacuation models over there, and then they like give you the initial like box, like you can't rely on these results initially, because if someone comes and does something and then just sue you because the things that they tried didn't work, so it's kind of challenge, and ethically I don't know if that's.
You have this artificial intelligence between the output of the model and a recommendation for the validation techniques. And I'm trying to figure out how that learns, because what's the independent judgment of the right validation technique?
There's no objective criteria for right.
Yeah.
It's
So how do you train your AI?
So the regular recommendation systems ask user like, was this helpful, or do you like this? And that type of input might help. Like, did you find this helpful? And then you tick, and then that means that there's a network and there's a link between those two when it comes to recommendation. But that could be one option.
Yeah, to give an example of how it's going to be hard to benchmark the base system thing is that there are a variety of agent-based models, as you know, where the agents themselves are doing some kind of D&D on their own model of how the world works. For example, so that there are several economics students who have models where individual agents are acting like econometricians. So they're in fact building a small model of their own world, right? So I mean, so now you have this kind of layers of validation or verification, and I think there's no objective way to figure out whether that's.
Or it's not the objective way to verify. It's to validate. It's the objective way to find the right validation technique from even a bounded list. What's right in that regard?
The system is going to tweet that it's passed everything. It's the greatest there's ever been.
I love it. I'll buy it.
And then in the next ticket crashes.
Right.
Not my problem.
That's a new system. It's a different environment.
Okay, very good. Well,
Yes.
Thank you, Hamdi.
Thank you.
We'll go on for a little bit of further questions.